Hello everyone. Today in this session of class I am going to explain about interference of light. See, the definition of interference of light is very simple definition. Interference of light is defined as modification of distribution of intensity of light when two or more than two waves superposed each other. So this is what the actual definition of interference. To understand or to get the interference pattern, a coherent source is mandatory, essential. So to understand coherent source, I will consider a simple picture here. So first I will tell what is the definition of coherent source. So coherent means same type of source. So physically it is called coherent source. So the definition of coherent source is the two sources are said to be coherent source when they are continuously emitting waves with zero or constant phase difference. Those two sources are said to be coherent sources. To get interference compulsory, we have to maintain coherent sources. Clear? To understand the coherent sources, let us consider a bulb, electric bulb. Here, what the electric bulb we have taken. In front of electric bulb, let us keep one cardboard sheet. So this acts like a opaque body. This cardboard sheet acts like a opaque body. Now, if you make a small opening in front of this source, or you can make anywhere opening. So if you make a small hole, now the light starts passing through this narrow hole. So you know what is the wave nature of light. So when you switch on this bulb, what happens? The light waves can travel in all the direction. It means transmission of light energy in the form of waves. So that is according to Huygens principle. So now these waves can travel and they can reach this particular small hole which is made on the cardboard opaque body. Now here, according to Huygens principle, these spherical wave can get disturbed. When there is a disturbance, that disturbance can act like a source. Now it can produce secondary wavelets like this. So it can produce secondary wavelets. So here what I am writing, it is secondary wavelets. They are also moving with the same speed. Right. So now I want to consider another cardboard at certain distance in front of the first cardboard. This is first cardboard, this is second cardboard. So in front of the first cardboard, I will keep another cardboard. It means an opaque body such that, so here this is the equidistance point. So exactly from this point, I will consider two more openings. This is the exactly midpoint. So from the midpoint, I will consider equidistance. Here one opening and this is another opening. It means a small hole. Two holes are made on the second cardboard. So this is the first hole and this is the second hole. Let us consider this is the first source and this is the second source. Here we have taken only single source. Now what happens when these secondary wavelets can reach this? It means a single wavefront. So this is what the wavefront now. A single wavefront is splits up into two more wavefront. It means two more wavelets are produced. From the single wavefront only we are splitting. Isn't it? So that's why whatever the waves which are coming out from source S1 and source S2, now these two sources should have zero or constant phase difference, then that two sources can what type of nature? Coherent nature. I think I hope you understood what is coherent sources. If you split a single wavefront into more than two wavefront, so then whatever the light coming out from these two sources should have zero or constant phase difference. So constant phase difference or zero means, suppose the wave starts like this as a sinusoidal wave from the source 1, from the source 2 also same phase difference. It starts 0 means this one is also starts 0. Suppose it starts from 90 degree means from the second source also it starts from 90 degree. That is the meaning of the coherent. There is no phase difference between the first source and the second source when it is emitting radiations or when it is emitting waves. Clear now? Now, so what happens? Parallelly, I am going to tell what is the definition of interference here. Now, we got two sources, S1 and S2. So, what are the name of these two sources? So, these two sources are coherent sources. Clear now? So, coherent means they have zero or constant phase difference when the waves are continuously emitting from the sources. Now, these two sources can satisfy coherent condition. Now, after what happens, when the wave starts traveling in this direction, see here, the waves are traveling now, like this. Here also the waves are traveling now, like this. So, you can clearly observe, there is a superposition of waves. There is a superposition of waves. Superposition means mixing of waves. If there is a mixing of waves, that will cause us the distribution or redistribution of intensity. Here the intensity is uniform. Here the intensity is uniform. But here the intensity is not uniform. This is the region where the intensity is modified or redistributed, I can say. Because energy neither be created nor be destroyed. Whatever the energy here, the same energy here also, the same energy here also. But there is a modification in the distribution of intensity of light. So that modification in the distribution of intensity of light when two or more than two waves superposed, that phenomenon of light is said to be interference. Clear no? What is interference? Modification in the distribution of light intensity when two or more light waves can superpose is called interference of light. Okay. So now whatever the pattern we are getting, we can observe on the screen. Here in the screen, we will get alternative dark and bright regions or alternative or unequal intensities. Unequal intensity. Here the intensity is uniform, here also is uniform, but the here whatever the intensity is observed on this screen, this is what the screen. On the screen, somewhere will get bright and somewhere will get dark. So especially we are getting alternative dark and bright regions. I will tell why we are getting alternative dark and bright regions while explaining the experiment. Clear now? So I will conclude that interference is a phenomenon of light. Here the redistribution of modification of intensity of light when two or more light waves can superpose. And come to the definition of coherent sources. The two sources are said to be coherent. The two sources are said to be coherent if they have zero or constant phase difference when the waves are emitting from this. So when the light is emitting continuously with zero or constant phase difference, then those two sources are said to be coherent sources. So this is the possible case. So with the help of this condition, Young's made an experiment to explain the interference pattern, or to observe the interference pattern experimentally. So I will explain that one. Okay. So this is about the coherent source. Now here, if I consider two bulbs, if I consider two electric bulbs placed like this is bulb number 1 and this is bulb number 2. if they are coming up, the waves are coming like this, no, waves are emitting like this. If these two waves can superpose, then we never get the interference pattern. The reason is these two sources should not act like a coherent sources, because the light emitting from here and here should not have zero or constant phase difference. So when do you get the zero or constant phase difference? A single wave front can be split up into two wavefronts. Clear, no? If a single wave front is splitted, then that split two sources acts like a coherent sources. Clear, no? Now I will move on to the next part. So that is Young's experiment. So Young's is a famous scientist, was experimentally demonstrated how the interference pattern can be obtained experimentally. So that's why here Young's has made an experimental arrangement. This is what the experimental arrangement. So as shown in the diagram. Here the first one is, so in the Young's experiment, in the initial stage, he has taken the sunlight as a source. Here you have taken sunlight. This is sunlight. Clear now? So in front of the sunlight, he has kept a single cardboard and he has made a narrow hole. A small hole is made. So this is source S, but this is not a coherent because only one source is taken. So when the light coming out from this source, I mean S, is made to fall on the another cardboard placed with certain distance and such that they contains two narrow holes. One is S1, another one is S2. S1 and S2 means source 1 and source 2, such that these two sources are exactly equidistant from S. That is one of the very important thing we have to maintain to get the coherent sources. So the distance from S1 to S is exactly equal to S2 to S, then only you will get these two sources has to be considered as coherent. Now a single wavefront can split into two or more wavefronts like this. Okay, S1 and S2 acts like a coherent sources. Now in front of this double slit, so this is what the double sources or coherent sources, a screen is placed. So it is a opaque body, a plain sheet, opaque body, and on the plain sheet we can observe alternative dark and bright or symmetric patterns are obtained. Symmetric patterns are obtained. So it means intensity of light is modified. So this is what the simple experimental arrangement made by Young's. That's why it is called Young's experiment. So dear students, in the examination, so this is one of the important questions. So they will ask the question like this. So describe the experimental observations and experiment on interference pattern by Young's experiment. Clear now? So I want to repeat that experiment, how the experiment has been done by Young's. So the arrangement is made as shown in the figure. So he has taken sunlight as a source of light. Okay. Now when the a single cardboard is placed, contain a narrow hole, is placed in front of a sunlight. Now we will get a wave pattern coming out from the source. Now in front of the source S, a double slit is placed. So these two slits acts like a coherent sources. After the superposition of light coming out from S1 and S2, we'll get the interference pattern because these two waves get superposed, then the light intensity is modified. The energy or intensity of light is modified. So that's why I will repeat the definition of interference. Interference is the distribution or redistribution of energy or intensity of light when two or more waves are superposed each other. Clear? So later on, what happens to get exactly the interference pattern in a particular manner? Young's modified this old version into new version. So in the new version, he has taken the same concept, but the thing is, the sunlight is replaced by a monochromatic light. Monochromatic means a single wavelength. So like here he has chosen sodium vapor lamp. Sodium lamp he has taken. See, sodium lamp commonly you can observe in street lights. So the yellow color light is sodium vapor lamp. So the sodium vapor lamp is placed. And in place of a narrow hole, he has made a narrow slit like structure. A small cuttings has made here. So narrow slit. So now this light coming out from here is a cylindrical in shape. Here it is spherical in shape. Here it is a cylindrical in shape. Now what happens? When the waves coming out here from the single slit is made to fall on the double slit. It means on this cardboard he has made two slits. One is S1, another one is S2. Clear now? So this slit, one is S1, another one is S2. The distance between these two slits are very small. So let us consider that gap is small letter d. The distance between S1 and S2 is d, small letter d. Now in front of this double slit, he has made again a screen, or he has placed a screen with certain distance. That distance is capital D. The distance between double slits and the screen is capital D. So on this screen, he has observed alternative dark and bright lines. So alternative dark and bright lines. So this is dark, the gap is bright, dark, the gap is bright, dark, the gap is bright. So like this, alternative dark and bright lines are obtained. So these lines, he named it as fringes. So what is fringes? Alternative dark and bright lines. Here dark means there is no light. It means there is a what type of interference? Destructive interference. Bright means there is a bright light means there is a constructive interference. It means alternative dark and bright regions are obtained. That regions, Young's name it as fringes. These alternative dark and bright fringes are obtained because the interference of light. It means here the intensity is uniform, here the intensity is not uniform. Somewhere it is maximum, somewhere it is zero. So this modification of redistribution of intensity of light is said to be interference. So it was experimentally shown by Young's. That's why this experiment is called Young's experiment for interference of light. So in the examination, so this is one of the very important question. Clear now? So I hope all the students can understand this one. So in the next video, I am going to explain how this fringe width. So I will tell the definition of what is fringe width here only. Suppose it is a dark and the next gap is bright, dark, bright. Say this is dark, bright, dark, bright, dark, bright. So this is dark, these are dark and these are bright. Bright means constructive interference. Dark means destructive interference. So these lines or gaps are said to be fringes. The gap between alternative dark. So alternative dark means here and here. This gap is called fringe width. Fringe width. So this gap is also called fringe width. Alternative, the distance between alternative dark and bright fringes are said to be fringe width. So this fringe width is represented by a symbol beta. This fringe width beta is equal to lambda d divided by d. So on what factor the fringe width depends on? It depends on the wavelength of light used. If you are using longer wavelength, the fringe width is longer. If you are using red light, the fringe width is wider. If you are using blue light, compared to red, the blue is having shorter wavelength. That's why the fringe width is smaller. So it means the fringe width is directly proportional to wavelength of light used. So monochromatic wavelength of light. And the distance between source and the screen. Here the source is always what? Coherent sources. The distance between double slit and the screen. If it is longer, the fringe width is also wider. If it is shorter or close to the screen, the screen is close to the double slit, then the width goes on decreases. If you move away, width increases because it is directly proportional to wavelength and the distance between screen and the double slit, and inversely proportional to the distance between two slits. If the gap decreases, fringe width increases. So this derivation is one of the very important derivation. In the next video, I am going to derive this equation: fringe width beta is equal to lambda d divided by d. So this is one